Okay, let's use your sum and difference formulas that we looked at in the previous video. I'm just going to use sine and cosine for our examples here, but tangent would be just the same thing. But we're going to figure out some of these ones that we don't really know right now. Like 5 pi over 12 isn't one that we've seen before. We don't really know how to put that on a circle per se and figure it out because it's not one of our special triangles. So what I'm going to do is I'm going to turn this into something that I can use the triangles that I already know. So what I like to do is if I see this guy that has a 12 on the bottom, I like to think about some of the angles that I already know. So what are some of the famous ones that we know? We know this one, we know this one, and we know this one. We could also do pi over 2 or pi or whatever, but we'll start with these three because a lot of times these three are going to give us what we need. Now, if I were to think about pi over 4 with a 12 on the bottom, we know that that would be a 3 pi over 12. This would be a 2 pi over 12. And this one would be a 4 pi over 12. And what I'm going to do is I'm going to try to see if I can combine these either by subtraction or addition so that I could get a 5. If I don't see ones that I can combine here, which obviously everybody does, right? To get a 5, I could actually bump it up to the next set of angles that you know. So after pi over 4, the next one that you know is 3 pi over 4, right? That's the one in quadrant 2. And that one, of course, everybody would know would be 9 pi over 12. And then you could bump this one up. What would that would be? The 5 pi over 6 would be the next one. So that would be a 10 pi over 12. Do you see what I'm doing here? I'm looking at the angles that I know how to find the sine and cosine for, and I'm converting them to 12 so that I can kind of look at them. So that one will be 8 pi over 12. And guess what? A lot of them are going to have a 12 on the bottom simply because 4, 6, 3, those all have 12s on the bottom. And they're going to give you ones that you're able to work with, most likely, right? So, but we see here that these two will add up to 5 pi over 12. So I'm going to think about this one. Instead of 5 pi over 12, I'm going to think about it as 3 pi over 12 plus 2 pi over 12. You want to see what we're doing here? So if I think about it that way, then we know that the other way I could think about it is actually as sine of pi over 4 plus pi over 6. And again, I could switch these the other way. It doesn't really matter because they, addition, if I add them the other way, it's the same thing. So once I've decided how I'm going to break the angle and I've decided whether it's going to be a plus or a minus, now I'm ready to think about what formula I want to use. Obviously, I want the sine one because this is a sine. And obviously, I want the plus one because I picked to write it as a plus. I could have also, I guess to get a 5, I could have done 9 minus 4. That would have been giving me a 5 also. It would have been fine, and I would have got the same answer, actually. All right, so what I'm going to do here is I'm going to use the one that I picked, though, and I'm going to use this formula that we saw in the last video. So my u here is, of course, pi over 4, and my v is pi over 6. So I'm going to do sine u, well, sine of pi over 4, and let's think about our unit circle, right? This one is an easy one. These are all in quadrant 1. So sine of pi over 4, if this is pi over 4, we know this is a 1 root 2. I know that these are positive, so my sine is going to be 1 over root 2 for pi over 4. Now again for pi over 6, quadrant 1 again, so pi over 6, this is going to be a 1 root 3, 2. These are all positive, so my cosine of pi over 6 is going to be root 3 over 2. So I'm just using my unit circle to find the ones that I know how to do, right? And then what do? We add that, and this time we want the sine of v, so the sine of this one, so it's 1 over 2. And the cosine of the other one, so that one is again 1 over root 2. And again, if your teacher requires rationalizing, you can rationalize, but as we all know, I don't really think that's all that much important, so I don't usually do it unless there's a reason to. So I'm going to do root 3 over 2 root 2 plus 1 over 2 root 2. And then this can be simplified if you want to write it as 3, 2 root 2. I mean, not 3, 4. What am I talking about? Add them together, right? Oh, no, it's not 4. It's 1 plus root 3. I'm losing my mind here. Sorry, guys, because we can't combine these. 1 plus root 3. Looking at the wrong thing. Over 2 root 2. And again, if you want to rationalize this, which if it's a multiple choice or some kind of exam that you're going to be taking online, so if you're doing Khan Academy or any of those things that are multiple choice, of course they're going to rationalize. So how would I do that? So I would have taken this on an open response. That would have been fine. But multiple choice, or if you're looking for your answer in the back of the book, you're going to have to rationalize. So you might as well practice. It's always good to practice. And these become 2, right, when I multiply root 2 by root 2. So I have a 2 times a 2, and that will be a 4. So that will be what your answer will most likely look like if you're looking for it on a multiple choice, or if you are looking for your answer in the back. So how do you feel about those? Pretty good? So that's how we're going to go about these ones. We'll do one more, and then just to make sure that we have it seared in our brains, right? Let's do a cosine one, I guess. Let's do cosine of, I don't know, 13 pi over 12. 13 pi over 12. So again, I'm going to start by looking at my angles. They're all in 12. So I'm looking to get a 13 pi over 12. So I'm looking how I can combine these things to get a 13 pi over 12. So I see, I'm going to go with this one and this one. Again, you can do subtraction if you want and get it that way, but I'm going to go with these two. So I'm going to do my 5 pi over 6 and my pi over 4. Okay, so I'm going to rewrite this one as cosine of 3 pi over 12. I usually, if I can add rather than subtract, I don't know, I just usually do. I don't know why, but that's just how I usually do it. So that's actually, if we're looking at them as the angles that we know, these are the angles that we usually call them, right? That's how we usually call these angles. Okay. Now for cosine again, I want the plus 1, so that means I'm going to have the minus. So I'm going to write it here so we remember. Cosine of u plus v is going to be cosine u, cosine v minus sine u, sine v. All right, so we don't make a mistake. I always encourage you to write it down until you know them super, super well, because it's easier to use your eyes than your imagination. So if you're trying to remember the formula rather than just looking at it, so even though I did it from memory, I wrote it down so that now I don't have to use any brain energy to remember. All right. So again, let's look at our pi over 4. That's just in quadrant 1, easy. 1, 1, root 2. So that's my pi over 4. And now let's draw our 5 pi over 6, which is going to be over here. So this is going to be pi over 6. So this will be a 1, root 3, and a 2. This will be negative, but this will be positive. So now I have all the information I need to do this one. You ready? Let's go. Cosine u. Remember, this one is u, and this one is v. So I will label them such, again, just so I don't have to use any brain energy to try to remember what I'm doing. So cosine u is going to be 1 over root 2 times cosine v. So that's going to be root 3 over 2, a negative. And that whole thing minus. Over here, we're going to have sine u, so that's this one, 1 over root 2. Sine v, so that's going to be a 1/2. It's opposite over hypotenuse, of course. Now let's simplify. Ready? So this is going to be, again, negative 3 over, so I'm going down here, over 2 root 2 minus, and this will be 1 over 2 root 2. I'm sorry, I lost my root 3. I don't know why I'm having a hard time with these root 3s today. Keep losing them. All right, so this one is negative 1 minus root 3 over 2 root 2. And once again, that's not the answer you will find in any of your textbooks or any of your multiple choice questions. So I'm going to rationalize, even though I don't necessarily believe in it that much. So I'm going to have negative root 2 minus root 6 over 4. And you have to admit this one looks nicer than this one, so you can see why people would choose this one. But For me, the rationalizing isn't as important, but obviously this is the way you're going to see your answer. Or the other way is, I mean, you can factor out the negative, but I doubt anybody's going to write it that way. I think this is the way you're going to see it. Okay? So go and try some and see what you think.